Hello everyone, my name is Dany Perwita Sari and I'm researcher in Indonesian Institute of Sciences, and I'm doing this research collaboration with Irvannie Gunawan and Professor Yun-Shang Chiou from National Taiwan University of Science and Technology. So our research title is Investigation of Ecohouse through CFD simulation. As we know from Indonesian Energy Outlook in 2019, data shows that household, about 42% of the total electricity in Indonesia come from residential sector, and about 33% about from industry, and the last one, commercial, hold about 25%. And we can know that modern house in Indonesia rely mostly on lighting fixture and air conditioning. It means more energy is used to drive mechanical appliance and increase greenhouse gas emissions. As we can see in Indonesia, there's a lot of traditional house from Sumatra, Java, and Irian Jaya. As we can see, all regions in Indonesia have traditional houses, and various studies have shown that vernacular house consume less energy and leaves a little environmental impact to achieve good indoor thermal comfort. From this figure, we can see a key characteristic of vernacular architecture is its location-specific climate-responsive design strategies. They always design their house based on trial and error. So we can see that they can adapt very well to local climate. And this is one example of traditional houses. And strong characteristic of an Indonesian dwellings are naturally ventilated and elevated floors, since we live in tropical climate and most of season is summer and the other is raining. So these both strategies show best to reduce, to get the thermal comfort. So these two characteristics also appear to have a strong impact on effectiveness of indoor air movement. So based on that concept, I designed Ecohouse. It is a prototype house that already built in Indonesia, in Research Center for Biomaterial in LIPI, Cibinong. And this design is based on climate adaptation strategies. This is the location of the Ecohouse in Cibinong, and they design based on open plan concept, and they have open kitchen, and it's designed by adapting to Indonesian vernacular house, raised floor and natural ventilated, and then unique insight into wind behavior in an actual house. So we built this house to analyze not only concept, but also how it will be built in reality. And we analyzed the wind flow also based on DesignBuilder CFD. Some opening I designed in this house, such as horizontal louver, and then open ventilated roof, and then raised floor. And this house also built based on fast-growing trees, which refers to a traditional house in Indonesia, and only one-story building with gable roof, small window, open plan floor, without ceiling and elevated floor. To analyze the wind flow inside the building, we should know the Bogor weather data. Since Cibinong located nearby Bogor, so this research used Bogor weather data. And wind direction majority came from the south. The rectangular plot of Ecohouse runs south to north, so it's perfect. And then the average temperature is about 26 Celsius every month. and daily highest daytime temperature can reach above 34 degrees, while the lowest can drop below 20 degrees. And then after I got the basic data, I calculate using power law, so I can find the wind profile of Bogor. And then I choose one family to represent they live in this house. So I choose one family which consists of father, mother, son, and woman. Woman, this means nanny from the son. And then I got this data from one of family in Jakarta. So I assume I use this family, live in this eco house, and I simulate using DesignBuilder. First step, investigate the wind behavior. We're using DesignBuilder CFD as a simulation program. And then the simulation begin with simplify the building geometry, and then calculate the mass using this program, and using external and internal analysis. And we use non-uniform group system. The best part of DesignBuilder compare with other data like other simulation tools like Fluent. This DesignBuilder can generate automatically calculate the grid and the mass, so we don't have to calculate manually like Fluent and Gambit. And then after that, I also doing validation. Before doing the simulation, we collect the data and validate the result from the DesignBuilder simulation. So first, I simulate the energy consumption of this house. During that simulation, I can find the temperature result, and I compare with the tools like hobo temperature, and I put in several places in this house, and we can found the result that the temperature between simulation and actual measurement close to the typical day was selected. So we can see that the simulation works and nothing wrong, because the result is almost similar, just different around 12 to 2%. And then we continue the simulation using CFD. And this is the result of external analysis. CFD simulation have been conducted to evaluate the wind flow around Ecohouse. So the wind direction comes from the south, and speed range is about 0.75 meter per second to 0.82 meter per second. And then the result compared with anemometer measurement data from Indonesian meteorological data, and the result is almost similar. So this external simulation also validated. Move to internal analysis. I slice this house plan become 3 slices to know the more detailed result. First slice is cutting from living room to bedroom. Second slice from living room and second bedroom. And the last slice is from kitchen and bathroom. And this is the result. We can see the wind flow around the house. The strongest wind velocity is occur in the front area, means living room. And then increase wind reach inside the house. Wind velocity mostly comes from the horizontal wind nearby the glass window. And this is the other result analysis. The temperature beneath the floor has cooler than on the roof. And a particular movement can be observed passing the living area south and flowing out by the opening near the kitchen. And DesignBuilder also can predicted percentage of dissatisfied. So we assume there's people live there. There's a family member that I already showed before. And predicted percentage is based on ISO 7730. And red color means more dissatisfied person, and then the blue color little dissatisfied person. So most of the zoning area in this house, like living room, bedroom, and bathroom, show only 22 until 40% dissatisfied. But for kitchen, because it's outdoor, it's about 65% dissatisfied. So I think the open plan concept that I suppose to reduce the hot from the electricity from stove and other appliances, so it's not effective enough. So better that make the kitchen is more closed, not semi-open. And more detailed internal analysis show that the heat flow from inside the house also move to the ceiling. So from the roof below the floor, and then move the opening to the roof. So a combination of the horizontal fin in the window and open ventilation on the roof reduce the temperature inside the house significantly. So the conclusion from the research is raised floor contribute to creating better thermal comfort through heat transfer from ground to the roof. And simulation results show that lower temperature beneath the floor if compared with other space. Open ventilation on the roof can significantly influence wind flow inside the Ecohouse, and horizontal fin near the window is increased internal wind velocity. Both the raised floor and roof ventilation play a crucial role for wind movement, and it should have received more attention from the building designer and research community. Further investigation need to be performed for other kind of ventilation design and different height, since it contributes to reducing the temperature. Okay, thank you for watching my video. Have a nice day.